Hey guys, welcome back. So in this video, we'll be looking into the swapping, wrapping, and bridging. But before that, we have to go and talk about smart contracts in general. Okay, smart contract is not actually smart. Okay, smart contracts just means that it's written using code. Okay, and the programmer who writes that could be smart, and that's how the smart contract becomes smart. Okay, so smart contract or a code contract will have the set of instructions to follow when receiving a parameter. Okay, so this is how generally smart contract is written. Let's say you are sending one dog, one goat, okay, as parameters to the smart contract, and the same parameter you are passing it to a dumb contract. Okay, the smart contract will understand that the one dog has to be uh, kept inside house, store it inside house, and for goat you could either sell it or keep it outside. Okay, and feed something like dog food, and for goat you generally put leaves. Okay, so this is smart contract because you have covered both the scenarios where you will receive a dog or goat, and you have handled that. But here in the dumb contract, they generalize this. Okay, they either let both of these creatures inside house or leave them outside house and feed leaf to both of them or dog food to both of them. So uh, it's totally dog food leaf, so they might write something like this is dumb contract, and situations like this is not handled here. Okay, and if you know what is a token is a standard thing. Okay, so standard means like you have heard, right? ISA standard, ICO standard, like that. So there should be a set of functions that is present on a code that should evaluate the parameters like that, and it should return this value. So this is set of rules or standards defined, and ERC20, ERC721 or something like that. Okay, so if you check into ERC20, there should be a function called balance of. Okay, it should receive address, and it should return balance. Okay, so it's a standard, and it should also have a transfer function, transfer from. I'll explain this why this is in this, these functions are required, and approve, burn, mint. Okay, so these some things are not standard, it's an upgraded version. Okay, now if you go to a bank and the bank is having an ATM. Okay, you go to your bank, they have their bank internet connected computer. uh, as a stick person, you have your $10, you deposit that to bank. Okay, bank will store that information in a cloud box or server, their server that will be shared across nation. Okay, now after you deposit that information is stored here. Before storing that, this cashier will check you have given the correct currency, and the number is correct as you filled, and they will say okay, $10 has been received and I have put into the counter. Okay, later we will put it in the reserve. Okay, now this information is sent to the server. Now you, same guy goes back. Okay, we used to do that, when you were kids. Okay, after you deposit that, you will check whether that deposit has been a success. Okay, go back to the ATM, check the balance, you know the balance. Okay, this currency didn't exist before, so this cashier has received physical money from you and uh, kept it in his account book, or like the bank locker, but it's a physical note. It's stored in the locker. Okay, but this information is now digital, and this digital information is available in the ATM. And from here, if you download, like take that $10 out, it will be a new note or old note, but it's another physical note that is present in the ATM locker. Okay, so these two values represent the same thing, but both are physically different. Okay, so to do the same kind of functions, like we'll also look into approve. Okay, now you go and buy a bike. For that, you have to give a check that you will sign. Okay, uh, $10 per month you can take. This is my sign. Okay, and once you signed it, this vendors can go to the server or the bank and take the money, $10 every month. Okay, now we'll come back to the code. Okay, so this process of you depositing a new physical currency into their machine means they have to give a digital commodity to you. Okay, so that is called minting. Okay, they mint new digital coins after you given them the physical notes. Now you have taken that outside. It's no more a digital $10. This $10 they will match it with their reserve, and this $10 that is in the ATM is now with you, so they will burn this token. Okay, because it's not, their digital value doesn't represent anything anymore. Now you buy, you're giving a check, and this $10 or $1,000, up to $1,000, this bike seller can take it from me. This bike guy, you are approving him to take money on behalf of you. Okay, so he can take it the same digital currency. If the digital currency present, he can take. But before that, you are giving this check, right? The approval. This is the approve function. Up to this, he can take from my account, but doesn't have to exist. I will deposit later, like before the EMI is been debited from my account. I will do that time. Okay, so you are giving the approval beforehand. So this is that thing. Now he is taking the money from your account, right? This is called transfer from. Okay, transfer from this guy's account to my account or any account I want, because I have the authority to take money from his account. He has given me the approval. Okay, now the transfer function now the transfer function means that you want to do a digital Google Pay transfer or Apple Pay transfer to some of your friend. So you are sending a digital commodity of $10 to his account. So this information is also updated here. Now that amount will be deducted from your account, user 1, and added into second player, user 2. They don't have to burn or mint any new tokens because it's just been transferred from your account to their account. So this transfer function is generally done by you. And balance off is generally used everywhere. Okay, so they will check the balance, and ATM will check the balance, he will check the balance. All these functions will check your balance before doing something on your account, because you have to have something in your account. So this is called ERC20 token standard. Okay, so these set of functions needs to be present, and these parameters are standard parameters and needs to be supported. Only the standard ERC20 tokens can be listed on our platform, because okay, you have all the functionalities of bank, and we'll approve that. Apart from this ERC20 standard functions, you could have any other function you want, but these functions should act the same way across. Okay, so since we now know what is an ERC20 token and how it's compared to a real world banking system, we look into the next thing, the swapping, wrapping, and bridging. So, what is swapping? Swapping generally means that you are transferring something to get some other thing, right? So, the same thing applies here also. So, swapping, you transfer what you have to the second person and ask him to send something back. Okay, but someone has to initiate the transaction. Whoever is sending that first is the sender, and the second person is just giving the value back or something with the equal value. Okay, so that has to be agreed by these two parties, but in most of the cases doesn't happen. Okay, someone might cheat, someone might not send the money because this is blockchain and everyone is anonymous, just with identified with the address. Okay, so to do that, we use this concept called smart contract. Like we discussed in the last slide, a smart contract is smart because it knows, it handles things well. And so here, a smart contract will be present between the you two guys, or maybe used by all other people, but you send your ether here. Let's say this second guy is Tesla coin, having Tesla coin. Okay, so he will send you, okay, 10 Tesla coin, and inside this contract it will first expect your token. Okay, I got one ether from you, and wait for the second Tesla token. So I received Tesla token. Now as soon as the second person sent, it can trigger like, okay, now this commodity value matches and this is satisfied. Okay, now transfer it to his account. You go to his account, so now this transfer is done. So you have successfully swapped a token with the other blockchain user. Okay, so this contract is generally a platform or a individual code that can be written between you two guys or for this general purpose. But in our IT world, this swapping, client will ask, okay, we are selling these tokens, and we want to accept these coins as payment. Once they send this payment, we want to send back this much value to their account. Okay, so this smart contract could also be a ERC20 token. Okay, so the ERC20 tokens, which has additional function of trading, okay, or swapping. So since now we know what is swapping, this swapping could only be done with a uh, token, ERC20 token, or a native cryptocurrency. But what about Bitcoin swapping with the Ether, or Ether swapping with the another coin, coin, something like that? Okay, so that time we come to the topic called wrapping. Wrapping is a concept that is like, okay, these guys are using this network and I need to convert my token to their value. What do I do? You got a provider or someone who will buy your real currency and give you that value amount tokens. Okay, so we'll take a scenario where you have a Bitcoin. This Bitcoin cannot be used in a Ethereum based network or the swapping things. Okay, so you use a provider. Okay, let's take some Binance or something. Okay, for example, I'll take the name as Binance. Okay, you send this one Bitcoin to here. He will take that one Bitcoin, store in his vault. Okay, and from his vault he will take something out if he is not having a sufficient balance, or uh, he will be transferring from his vault to your account. Okay, as a wrapped BTC. Okay, so this wrapped BTC now is with you. Okay, but this wrapped BTC, he can just give anything. Okay, this is my new token, wrapped BTC. You just use it, but they have to accept this. This smart contract that you are trying to interact with needs to support. This is okay, verified token. I will accept this as wrapped BTC, because anyone can deploy a token and say this is the wrapped BTC. This has to be verified. Okay, so you have to go to a trusted provider to send your Bitcoin, else this Bitcoin, once it's sent, it's lost. Okay, now you have found a trusted provider, and you have sent the Bitcoin to him. And okay, he's taking that one Bitcoin, he stores in his vault, he's creating a digital currency like we saw in the last slide. The bank receives the physical note and provides you a digital currency to use. Okay, that digital currency is wrapped BTC, that is used in the network. Okay, the network of the smart contract deployed. Okay, now you got a wrap BTC. So now this one Bitcoin is not there, we'll remove him also from the picture. So you got the wrap BTC now, right? Now you can send this wrap BTC to the network. This will check. Okay, like we saw in the last slide, same thing. We send a goat, dog, anything it should handle. So we'll send one wrap Bitcoin to here. They will check what is the Bitcoin value right now, because it's just a wrapped Bitcoin. So you have to get the exact same value as the real Bitcoin. So they will take, okay, one Bitcoin is equals to some amount of token what you are expecting back. You can just ask them, okay, I need to get the Tesla coins only. Okay, you send 1,000 Teslas, or you create new tokens. So this is up to the smart contract the tokens to decide what and what way this 1,000 tokens can be given. Okay, so now you got 1,000 tokens swapped from the smart contract. Okay, so now this Tesla ERC20 token, you have that with you. So now we want to do one more thing. You want to wrap this also, and you want to participate in another network. Let's take this as Polygon. Okay, so this is another smart contract which accepts Tesla coins for real car. Okay, so this is now managed by Tesla. Okay, so you send this Tesla coins to him, and this guy has to tell that, okay, I accept this kind of Tesla token, so you send me that, I'll give you a car. Okay, this car could be a digital asset as well. Okay, so he will send you, this is your car, and this is the VIN number. VIN number is the vehicle identification number. So this car is now registered on your account, so for your name. Okay, and this is the proof of that. Now his account, he has a car, digital car. Okay, if he takes that one digital car. Okay, so this car details, he can go to the real physical showroom and get that. Okay, he can keep this digital currency as a proof of buying a real car. Okay, now we started from transferring ether to this guy, get 100 Tesla coins back, or you send that ether to here and get 1,100 Tesla coins from here, or you wrap your Bitcoin to a Binance and get wrapped Bitcoin and transfer that wrapped Bitcoin to here and obtain the 1,000 Tesla coins. Then finally you can buy a car from Tesla using their smart contract. So this is Tesla smart contract. So that accepts only the Tesla coins. Okay, so now we have looked into swapping as well as the wrapping part. Now what about bridging? We'll see that now. Okay, in this process itself we have did a bridging. Undo. Okay, so now we come back to Binance. Okay, in this Binance you did a conversion from Bitcoin network, or the BTC coin from Bitcoin network to Ethereum network. Okay, so transferring one coin from one network to another network is called bridging. Okay, now we know. We'll rehearse all these things once more. You got one ether, somehow you got it. Okay, you want to buy say Tesla car, so you are transferring that to a smart contract which is written by a smart person like you. Okay, so this will transfer you back 1000 Tesla tokens, and this is called bridging. Okay, now wrapping, you are having one Bitcoin and you want that to be usable in their network. Okay, this is Ethereum Forte, Kalakilla. Okay, so this one Bitcoin you are sending it to a vendor like Binance, who supports or who has the original wrapped BTC that is supported by Ethereum network. Okay, so you send them on Bitcoin and you get one wrapped Bitcoin. Now you send this wrapped Bitcoin into the Ethereum network and get 1000 Tesla coins to your account. Okay, now you are part of the Ethereum family. Okay, then this 1000 Tesla coins you have right now, you send it to Tesla smart contract, which is also written by some smart people like you. Okay, so they will receive this 1000 Tesla tokens and will create a digital asset, which is now called also NFT, fungible tokens. Okay, so they will say that okay, this is an NFT or a digital asset. Now this digital asset is now registered on your name, so they will say okay, this win number 12345 is now registered for John, or the details you gave with this buy function. Okay, you buy. Okay, buy Tesla, and this is your proof of owning the asset. But this contract needs to be from Tesla itself. Okay, they will only accept they okay, we sold you car. Okay, anyone can't deploy a Tesla contract and say Tesla now owns your car. Okay, now this identification is now as part of your account address, which is generally 0x123 something like that. Okay, you go back to the store, the physical store, where you don't have to argue at all. They will say okay, you're John. Okay, this is your VIN 12345 that you have bought using this blockchain. You have sent us 1000 Tesla coins for this particular Q8 model, something, I don't know the model. Okay, so this car is now registered for you. Okay, you can drive it home. Okay, in case someone asks how did you buy it, you can show this is the way you bought it and this is the proof you have. Okay, so you have given us the 1000 Tesla coins and we have transferred you an asset back. Okay, and this part where you convert a Bitcoin to a wrapped Bitcoin that works with Ethereum network. From network to network, it is called bridging. Okay, so now you know what is swapping, wrapping and bridging in general term. Okay, so if you want more technical and other stuff, you can comment it down. I'll try to cover that also. In the next video, I'll try to cover what is MetaMask and why it's used in simple terms. Okay, so based on your feedback, I'll improve my video. If this video was helpful, please like and subscribe. Thanks for watching.